This is group one, which consists of Adrian Buendia, John Giuliano, Sidney Jean, Carlos Moncada, Juliet Perez, Veronica Boydamani, and Daniel Ramirez. So this video will cover the design for high-speed automatic assembly and robot assembly, which is chapter 5 of the textbook. So for automated assembly, it often forces reconsideration of design because you need to consider the ease of automatic feeding and orienting. And this picture below is a great example. So it's easy for a person to tell that the part on the left is asymmetrical and the part on the right is symmetrical, but for a machine, this difference would be very hard to detect. So the symmetrical part would be a great redesign because it's easy for the machine to orient. Some potential feeding difficulties are thin edges, which is also called shingling, or the parts overlapping. And these difficulties with feeding parts will ultimately lead to increased costs.
So for general rules for product design for automation, we want to minimize the number of parts, ensure this product has a suitable base part to build on, and that this base part has features to make it easy to locate and a stable position to build on. And you can see this with the work carrier and the base part in the top right picture. Assembled in layers if possible, introduce guides and chamfers that aid in automated assembly. And this can be seen in this bottom right picture, as the old design has sharp corners and the new design has chamfers that let the spring easily fall in, and then screws that centralize themselves, including the dog point, cone point, and oval point. So for feeding and orienting, the most versatile feeder is the vibratory bowl feeder. And when considering this, we want to avoid designing parts that would tangle, nest, or shingle, as seen in the bottom right. We have the open-ended spring that will tangle, so the redesign would be to close the ends. And then same thing with the washers. We have the open washer, and then so we want to close the washer. And if parts cannot be made symmetrical, avoid slight asymmetry or asymmetry resulting from small or non-geometrical features. For product design and robot assembly, it has pretty much the same guidelines, but there's a couple more to consider with the robot. So we have reduce the part count, include features such as leads and chamfers for self-aligning, ensure that parts that are not secure immediately on insert are self-locating in the assembly, design parts that can be gripped and inserted using the same robot gripper, so we're saving time with not having to change out the robot head, design products to be assembled in layers, avoid need for reorienting, design parts that can be handled in bulk so that there's no tangle. If using automatic feeders, ensure parts can be oriented with simple tooling and delivered in a way that can be gripped and inserted without manipulation, and a stable resting aspect if being presented in magazines or part trays. For the credit slide, we have our team members. Adrian Buendia created references. John Giuliano and Veronica Boydamani did voiceover. Sidney Jean, Carlos Moncada, Juliet Perez, and Daniel Ramirez did the slide information. And our reference is the book, pages 185 to 218. Thank you.